When you're operating out of a busy airport, particularly one with a lot of airline traffic, the frequencies can get really crowded. No one wants to tie up the ground or clearance delivery frequency with lengthy, detailed departure clearances. Not only that, but when you have high traffic volumes, you'd also like the departing aircraft to follow an orderly traffic flow instead of all scattering like a flushed covey of quail. So the FAA has devised a very nifty way to accomplish both those goals in one package: the Graphic Departure Procedure. Graphic departure procedures used to be called Standard Instrument Departures, or SIDs, and you'll probably hear old-timers still call them that. You'll find these graphic departure procedures in your approach chart book. For instance, here is a departure procedure for the Helena, Montana Regional Airport called the Stack 2 Departure. You can see the name at the top left, and in the same area you see in parentheses stack2.stack and pilot nav. Stack2.stack is the code that tells the ATC computer the route you'll be using to depart the airport. The procedure is called the stack departure because it ends right here at the stack intersection. The 2, as you see here, is the version number. Each time they change it, they increase the number. And the second stack means you'll transition to the rest of your route from stack intersection. In your flight plan, when you give the flight service station person stack2.stack as the first part of your route, ATC will know exactly what departure procedure you want to fly. If you use DUATs and file your flight plan yourself, you may need to use a space instead of the period to get the computer to accept it. Pilot Nav tells you that you are primarily responsible for your own navigation using the published route on the chart. Now, take a look in the upper left-hand corner. That's where you'll find the frequencies you'll use on this departure, including the frequency for departure control. But remember, when you're taking off on an IFR clearance, don't automatically switch to that departure control frequency. The tower will tell you when they want you to change frequencies. Let's take a look at the plan view area on this chart. Now, the basic part of the departure procedure is shown with these heavy black arrows. Now here you'll see there's a routing coming out of the airport to the east and another coming out of the airport to the west that turns back to the east. Both of them track outbound on the 087 radial out of Helena to stack intersection. The basic departure procedure ends at stack intersection here because that's where the heavy black arrow ends. From there, you have various transition routes depending on exactly where you're going. For instance, if you wanted to go to the Lewiston Vortac after stack intersection, you would turn left and follow the 15 DME arc to the 058 radial from the Helena Vortac, which is Victor 113, and then track Victor 113 all the way to Lewiston. Now notice down here in the departure route description section, it tells you this is called the Lewiston transition, and it describes how to fly the transition. When you file this departure procedure and transition in your flight plan, you would use the computer code stack2.lwt. Using this code lets ATC know you plan to fly the Stack 2 departure with the Lewiston transition. You'll often see minimum altitude and climb rate restrictions in a departure procedure, and you'll have to comply with those climb restrictions in order to be able to safely fly the procedure in the clouds and successfully avoid the dreaded cumulus granitus, also known as rock-lined cloud. For instance, there is a minimum altitude that you should cross stack intersection. Now in the plan view, below stack intersection, you see 10,200 with a line underneath. 10,200 feet is the minimum altitude to cross stack intersection. The written information down below tells you exactly the same thing. For example, if you're departing on runway 9 here, you must cross stack intersection at or above 10,200 feet. Here is another departure procedure, the Washoe 2 departure out of the Reno area. Next to the computer code, it tells you that this is a vector departure procedure. Now this means you will get radar vectors shortly after takeoff for your assigned route or to a fix on the chart. Let's take a look at the route you should fly if your assigned route is Victor 6 here. Well, when you take a look at the plan view area, you simply look for where the heavy black arrow goes. And the heavy black arrow starts here at the airport and goes southbound down to this intersection, WAG intersection. The textual description down below tells you the same thing. It says, climb via the Reno Localizer South course to WAG intersection, then via radar vectors to assigned route, which in this case is Victor 6. But what procedure should you follow if you lose communications on this departure? Well, look at the bottom of the departure, and sure enough, it says, in the event of lost communications. And then it tells you what to do. If you're not in contact with departure control by the time you get to 9,000 feet, continue your climb to WAG intersection, then turn left direct to the Mustang Vortac. And then, if you're at or above the minimum crossing altitude, proceed to your assigned route. If you haven't reached that minimum crossing altitude, you'll climb in a holding pattern at Mustang Vortac until you're at the proper altitude. Let's take a look back in the plan view at WAG intersection. Now, see this dashed line here? It leads back up to Mustang Vortac. That dashed line depicts the route to follow if you lose communications. And this is the holding pattern that you would be using while you climb to the minimum crossing altitude, if you haven't reached it by the time you get to the Mustang Vortac. Now, it's very common to have a minimum climb rate on an instrument departure. The problem is that the FAA can't tell you the climb rate in feet per minute because your ground speed during the climb makes a big difference in the distance you're going to cover. So what they have to tell you is the climb rate per nautical mile that you have to maintain in order to clear obstructions. And on this departure, right here in the lower right-hand corner, you'll see a note that tells you that you're required to maintain a minimum climb rate of 400 feet per nautical mile to 9,000 feet if you're safely going to fly this departure route in the clouds. Now, that's fine, but you don't have an instrument in your aircraft that tells you feet per nautical mile. Your information is all in feet per minute. So how do you convert that to something you can use? Well, one way to convert feet per nautical mile into feet per minute is with a very simple formula. First, divide your ground speed by 60 to get your speed in miles per minute. Then multiply that times the feet per mile. So let's say that in your climb you have a ground speed of 90 knots in your 172R. What is the minimum acceptable rate of climb in feet per minute to 9,000 feet? The departure procedure tells you that you have to climb at 400 feet per nautical mile. Now 90 divided by 60 is 1.5. And 1.5 times 400 gives you 600 feet per minute. So on this particular departure, if you had a ground speed of 90 knots in the climb, your climb rate would have to be 600 feet per minute. Now, I wouldn't count on being able to do that in a loaded 172. And remember, this departure procedure is from Reno Airport, which is at an elevation of 4,412 feet. If your airplane can't make the climb requirement, you'll need to figure out a different way to depart the airport and avoid the obstructions. Now, there's another way to get the climb rate besides using that formula. You can also look it up in the legend in the front of the NOS U.S. Terminal Procedures book. Now let's look at page D1, which is a rate of climb table. If you know your ground speed and the required climb rate in feet per mile, then this table will tell you what the climb rate in feet per minute has to be. For instance, if your ground speed is 90 knots and your required climb rate is 350 feet per nautical mile, what rate of climb would you have to maintain? Well, this is easy. First, in the left column, find 350 feet per mile. Come across to the right until you find the column for 90 knots ground speed. And where these two columns meet, you'll see your required climb rate in feet per minute, which is 525 feet per minute. Now, this Milwaukee departure procedure has something many DPs don't: an altitude to maintain. In this case, if you see right here, it's 5,000 feet, unless you've been assigned to a lower altitude. When the initial altitude to maintain and the departure control frequency are given to you in the printed departure procedure, as they are here, the controller will usually not repeat them separately in your clearance. Now, the first time that happened to me, I was sure the controller had made a mistake. So I called her up and asked her for an altitude and departure control frequency. I couldn't understand why she sounded so irritable with me, especially when I knew that it was her mistake. Well, the second time it happened, I finally got smart and looked on the departure procedure for that information. And now you're smart too. Now, departure procedures can be assigned by the controller even if you didn't file one in your flight plan. So if you don't want to use a published departure procedure, just put the remark "No DP" in the remarks section of your flight plan. That tells the controller to not assign you one because you don't want to fly it. Now, why would you not want to fly a published departure procedure? Well, just like in our WashU 2 departure, it may require climb rates that your airplane cannot meet. Or maybe you just don't have a copy of the departure procedure in your possession. As you know, the graphic departure procedures have both a picture of the route you are going to fly, and underneath this picture, a written or textual description. To accept the departure procedure, you must have at least the textual description in your possession. And that's what departure procedures are all about. You'll find them very handy because it's a lot easier and quicker to copy down just the title of a departure procedure instead of a full route description.